Okay, can you tell me about Ospf protocol a little?
It is a dynamic IP routing protocol, ma'am,
Okay, dynamic routing.
which maintains the finds the efficient route
Oh,
It's a
and
link state protocol, ma'am.
it is the link state protocol. Okay.
And it follows EGP. It's come under EGP.
Mm-hmm. What do you mean by EGP?
Ma'am, it shares data inside inside the same autonomous system.
Hmm. So it's EGP or IGP?
IGP, ma'am. Sorry, it's IGP.
Okay, it's an IGP protocol, interior gateway protocol. Then
it also directs the traffic in IP networks. Ma'am.
that is only is IP routing. Then others.
It updates the data only when it's any updates are required, ma'am. It only sends the request data.
What is that update called as? We have already discussed distance vector and link state, right?
Yes, ma'am.
When there is a change in the topology, update will be sent immediately. So what kind of update is that? What update type is that? It's called as triggered update. Yes, go ahead. What else? Anything else? Anything else?
It follows 3 tables, ma'am.
Okay.
Routing table, network table, and database table.
Routing and network table is one and the same.
Topology table, sorry.
Topology table and then
Database table.
topology table is the database table. Link state database.
Neighboring table.
Neighbor table
Yeah, neighbor table.
called as link state database, that is topology table. Neighbor table, that is adjacency database. Adjacency is nothing but neighborship. Okay, in Ospf terms. Then routing table, this is called as forwarding database. These are the Ospf terms for the same tables. Okay. We'll speak about certain terminologies in Ospf. There, these tables, generally when we call them routing table, topology table and neighbor table, link state uses its different names for it. Routing table is called as forwarding database. Topology table is link state database. And neighbor table is adjacency database. Okay. Link state database is also called as LSDB. Okay. For OSPF. Anything else?
It follows Dijistra's algorithm.
Okay. It uses Dijkstra algorithm for
finding the shortest path.
Okay. Dijkstra algorithm is for it uses two algorithms. Okay. So Dijkstra algorithm is used to find the
Shortest path.
best path. Okay, best path. And there's one more shortest path first algorithm. This is to calculate the cost. For cost calculation, it uses SPF algorithm. For after calculating the cost, now which path has the best cost or the lowest cost? Path with okay, path with lowest cost becomes the best cost, the best path. Okay, and that is elected using the Dijkstra algorithm. Okay. Yes.
And its AD value is 120, ma'am. It follows matrices of cost.
Check again. AD value of 120 is for RIP.
110, I think. 110, ma'am.
Yeah. RIP is 120. Okay. OSPF is
110.
110, which is lesser than RIP. So it's better than RIP. Then
It has 5 packets.
okay. We will not go in the packet types. Speak about OSPF. Anything more?
It has area, ma'am.
Okay. Okay. It works with areas. Types of areas we will discuss in a while. Okay. It works with areas means your routers are grouped into areas. Areas, or your autonomous system is further divided into areas. Okay. Then what is the maximum hop count it supports? So RIP is 15, correct? Okay. 16th is unreachable. Okay. For RIP, whereas maximum hop count here for OSPF is unlimited. Means you can have any number of routers. And one more important, it is open standard. What is open standard? It can work on any vendor router, regardless of Cisco, Juniper, Avaya, any routers it it works on any vendor router. Then what else?
It uses multicast addressing.
What are the multicast addresses used by OSPF? What is the RIP multicast address?
Uh, to send hello packets, it uses the
Correct.
multi.
What is the multicast address of RIP?
Designated routers and
Here,
OSPF route.
Monica, what is the multicast address used by RIP? RIP protocol. We saw the debugs, right?
Yeah.
What is the multicast address used by RIP? It's 224.0.0.9 is for RIP. Okay.
0.0.5.
KGRP is 24.0.0.10. OSPF uses 224.0.0.5 and 224.0.0.6. Okay. For point-to-point network, it uses .5. Okay. For multi-access network, we will discuss what is a multi-access network. It uses 6. Okay. Multicast addresses is 224.0.0.5 and 224.0.0.6. Both are used by the OSPF. Anything else? Okay, you said that no periodic updates, correct?
Yes, ma'am.
So, how does it build the routing table then? No periodic updates, then how do they build the routing table? How do they find the best path? Hmm? The sync at startup. Okay. No periodic updates. They synchronize their database when the router has booted, means when your OSPF process starts. And after the OSPF process has started, it will communicate with all the neighboring routers, fetches the information, builds the routing table, topology table, neighbor table, and then after that, no periodic updates. Next update will be only when there is a topological change called as triggered updates. Update will be triggered when a change in the topology. Means if any new network is added or if any old network goes down, only then a change will trigger an update. Um, okay. What does it send in an update? Just the state of the link. Unlike link is nothing but network. That is the term OSPF terminology again. State is called as link is called as the network is called as the link in your link state protocol. Unlike your distance vector protocols are sharing the entire routing table in the update, correct? Whereas this protocol will tell the neighboring router that so and so network is up and so and so network is down. That's it. Okay, consuming minimum bandwidth. Okay, cost is a metric.
And it
So
will ask IP router ID for each router.
yeah, metric is cost to calculate best path. Cost is considered, and every router has a unique identification. Okay, so every router only with that particular ID, RID. Okay, router ID. Then what else is missing here? Load balancing. It can have maximum is 6. Okay, but default it is set to 4. For load balancing means how many paths can be best paths to one single destination, maximum 6, but will be set to 4. Then anything else? Mm. No sphere. Shall I clear this? Okay, one more point. It works with hierarchical structure. That is one router will be connected to another routers. This is hierarchical structure. Okay. So it works with hierarchical structure. And then Okay. So the first term is link. Link is nothing but a network or connection. Okay, network you can say, network or subnet that is connected. Then adjacency, that is neighborship. Adjacent router, neighbor router. Link state database, LSDB. Adjacency database, neighbor table, then forwarding database, routing table. Then comes RID, the router ID. Then the router will look for the loopback interface IP address, because you know that loopback is a logical interface and will never go down, correct? One is manual configuration. Until unless the configuration is there, router can use. Now RID is a kind of identification. OSPF device will use it as its identification to show itself to the entire topology. So every other router will see the OSPF router using that name. Okay, so this acts as the identification of the OSPF router. So in case if the RID, let's suppose I've chosen some physical interface IP address. In case if the interface goes down, the router has to again go and look for another router ID. Yes or no? So physical interfaces are tend to go up and down. But when it comes to manual configuration, until unless the router configuration is there, the manual RID will be there. Now, second preference, if manual configuration is not done, the router will give the next preference to the loopback interface IP address. If you have multiple, then the highest will be considered. If multiple loopbacks are there, the highest out of multiple loopback interfaces IP address will become the RID. Now, even if loopback is also not there, then the last thing is highest physical interface IP address, IP, again, the highest one. Understood? Last preference is given to the physical interface. Let's suppose I have R1. Now R1 is connected to 10.0.0.0. So on fast Ethernet 0/0, its IP address is 10.100. Serial it is 200.200.200.1. And let's suppose it has a loopback 170 or maybe like loopback 0, 1.1.1.1. Okay, and loopback 2, uh, 2.2.2. Okay, loopback 1, 2.2.2.2. And okay, so in case if I've configured the router ID is like 192.168.10.1. So the first preference will be given to the manual configuration. This is the first preference. Second preference, if I have multiple loopbacks, this is the second preference. Means if manual RID is not there, then this will become the RID. Means if multiple loopbacks are there, highest of the multiple loopbacks. Even if loopbacks are not there, then I have two physical interfaces. Out of these two physical interfaces, this is highest. 200 is higher than 10. So this is the third preference. Now if I consider R2, R2 has three interfaces. One is 200.2 and the other one is 201.1. And here it is 20 network, 20.0.0.100. Looking at this, 201 is highest. So this becomes the RID. Understood? Only physical interfaces are there. Highest physical interface IP address. The interface should be up and up. Means both status and protocol should be up. Only then that interface IP address will be considered, otherwise not. Clear? And router will choose the RID when it is beginning the OSPF process. Means initially when the means OSPF process starts, then it will choose the RID. After that, it is not going to change it. So in case, let's suppose the router has already chosen the RID as 201, but 201 has gone down now. So I want the router to elect the RID again. So you have to restart the process on the router, OSPF router, or you have to reload the router. Okay. So how do you restart the process? You will say clear IP OSPF process. It will ask you whether you want to start all the processes. You will say yes. Okay. Then the process will be restarted. Means any changes, if you've done and you want your router to consider the changes, then you will have to clear the IP OSPF process. So router ID election happens. This is the OSPF routers identification. Routers identification in the entire topology. Then you have like hello protocol. Hello protocols are used to exchange hello packets. Hello packets are like keep alive. What do you mean by keep alive? To check if your neighbor is still alive. Okay. So every frequently one router will share a hello to the other neighbor. It will share a hello packet. If the hello packet comes back in reply, then my neighbor is all good. Okay. So that is about the hello protocol. Then then you have LSAs, link state advertisements. As I told you, like the router will share the updates, correct, when they are syncing. Okay. So the updates will be shared using the LSAs. So LSAs are used to share the routing updates, you can say. Routing updates are exchanged with LSAs. There are totally 12 types of LSAs, out of which uh, 6 are very important. So we will discuss those 6 types in some time. Okay. Link state advertisements. Then areas. OSPF has different types of areas. Major are transit area and regular area. What is a transit area? This is the area that is must area, means you should create the first area that you create on OSPF is a transit area. It's a must area, and by default, area 0 is transit. It is also called as the backbone area. What are regular areas? These are non-transit areas. What do you mean by non-transit? Means if I connect two areas, let's suppose I have multiple routers, I have put them onto two multiple areas. Let's suppose this is area 1, area 0, and there are two routers here. These are in area 1. Okay, and these routers are in area 2. So even if I directly connect two regular areas, now apart from area 0, all other areas are regular areas. Okay. So even if I connect them together, they will not be able to communicate directly. They will communicate via the transit area only. Okay, two regular areas cannot communicate directly. So it depends on transit area. Okay, that is why a transit area is must in OSPF. First area that you will create is area 0. After that, you can create as many areas required. But first you should create at least one transit area, and all regular areas will connect directly or indirectly to the transit area. They should connect to transit area somehow. Done. Shall I clear this? Done. Shall I clear this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
As I said, it uses the hierarchical structure. We have some more terms that we will discuss. Okay. So, as I was speaking about the area, so let's finish that first. So, I have one router. So, consider this is my backbone router. Why it is called as backbone router? Any router that is inside the backbone area becomes the backbone router. Okay. Over here I'm connected to LAN and a PC. Okay. Now let's divide them into areas. So consider this is area 0. Okay, which is the backbone area. Then this is area 1 and this is area 2. Okay, I'm using 10.0.0.0/8 network. This is 20.0/8 network, 30.0/8 network, 40.0/8 network, 50.0/8 network, and 60.0/8 network. Here I'm using 192.168.1.0/24, 192.168.2.0/24, 192.168.3.0/24, and 192.168. This will be 168.4.0/24. And these routers that are inside the regular area, now area 1 and area 2, these are regular areas. Okay. Now area 0 is backbone area, or you can call it as the transit area. These are non-transit areas or the regular areas. Then okay. So the routers R1, R2, R3, R4, which are located in this non-transit areas. These are called as your internal routers. The routers that are inside your the regular areas are called as internal routers. Okay. The router that is inside the backbone area is called as backbone router. Okay, and routers that are connecting two areas together, there's area 0 and area 1. Okay, so these routers are called as ABR routers. ABR1 and ABR2. Okay. Now, what does ABR stands for? Area border router. As it is at the border of the area, it is called as area border router or area boundary router, whatever you call it as. Now, let's suppose all these routers are connected, are there in one autonomous system. Okay, this is autonomous system. Okay, 100. Now there is one more autonomous system. Consider this is another autonomous system, AS 200, and there is one router here that is connected to one router in this area. Okay. Okay, so the router that is connecting from one area, one autonomous system to another autonomous system, that router is called as the ASBR. What is an ASBR? Autonomous System Border Router. Understood? This is the hierarchical structure.
So the Bangalore, nobody can have the address only as a Bangalore, right? It will be like house number 1, ABC Street, Bangalore, right? So nobody can have only Bangalore as their address because Bangalore belongs to the entire Bangalore. You know, it's the name of the.
Few more things that we have to discuss about OSPF. That after this lab we will do it. Okay. So first see how it works and on. Then we will explain it. OSPF configuration. You can do this in packet tracer. Same scenario. What did I show you now? The hierarchical structure. You have to do that. Okay. So syntax. On the router's configuration mode, you will say router OSPF, and you will choose the process ID. Anything from 1 to 65535. Not required that it should be same also on the routers, but EADRP had this clause. Process ID can be any number from 1 to 65535. Then you will enter into the router configuration mode. Inside, if you want, you can configure the router ID. See if this command is supported. Router ID. Then you can configure the RID for R1. That is 1.1.1.1. May not exist, but you can, even if the IP address does not exist, you can configure it as an RID. Then you will say network. And then you will advertise the directly connected networks. If you consider R1 has two networks, correct? That is 10 and 20. So you'll advertise those directly connected network address. Then hold on. You will not give the subnet mask in this. You will give the wildcard mask. I told you what is wildcard mask, correct? Reverse of net mask. So if I'm advertising 10.0.0.0/8, net mask will be 255.0.0.0. So wildcard mask will be 0.255, 255, 255. So you'll have to turn on here. N bits are on, here H bits are on. Okay. So you'll give the wildcard mask, then you'll say area keyword. You'll type area and then you'll give the area ID. That will go from area 0 to some 49 million, some number it is. Okay. So don't have to remember that number, but you can create multiple areas. Example. Let's suppose I'm on R1 configuration mode. I will say a router Ospf bed ready, whatever like I did. Even if you skip this command, if you have a loopback address, it will take that IP address, or else it will take the physical interface IP address. But if you want your router not to change the RID every time, either configure manually or configure a loopback interface. Then you'll say network. You'll say 10.0.0.0. Wildcard mask is 0.255.255. 255.255.255 area 0. This tells that this network belongs to area 0. Similarly, for 20.0.0 network, area 0. Remember the previous scenario. AVR R1, R2. This is backbone router, correct? So this is one area, right? Where 10 network and 20 network is there. This is 30, 40. Here you have 192.168.1 and 192.168.2, correct? When I'm putting this into areas, so 30 network, 40 network, 192.168 and 192.168.2, all this will go in area 1. Means when you're advertising, remember that areas are the ones to which the networks belongs to. 10 and 20 are in area 0. Whereas 30, 40, 192, 168, 192, 168, 2, all these are in area 1. So when you're advertising, make sure that which area the network belongs to. The router does not belong to an area. Routers links or routers networks belongs to areas. Okay. So you have to be very specific with that. Okay. Then what are the verification commands?
IP route.
Verification commands are
Show IP route, show IP protocol.
show IP route, show IP protocol. Before that, show IP interface brief to check if your interfaces are up. Whatever interfaces are up, only that will show in your routing table. Okay. Then you have few more with Ospf, show IP, Ospf, neighbor. This will display the neighbor table. This is for routing table. Okay. This is for neighbor table. Then show IP Ospf database. This will be your LSDB. Link state database, that is your topology table, will be displayed. You want me to show the configuration or first? You don't have to give no auto summary. No auto summary means auto summary is by default disabled. Auto summarization is disabled by default. in OSPF. Okay. Auto summarization is by default disabled in OSPF. So you don't need to give auto summary. Clear? Because in OSPF, summarization happens at only two places. One is at the ABR and the other one is at the ASBR. Okay, finish this lab soon. Okay. Design the scenario and then maybe you can go for the lunch break. Design the scenario, do the basic IP configurations. Okay. Set all the IP addresses up, all the interfaces up. Then, in case if you're able to finish it in 20, 15, 20 minutes, then you can go for the lunch break. Okay. But design the scenario. Once you come back, then you can do the OSPF configuration over it. Yeah.
We have to do this in GNS or packet tracing?
Do it in packet tracer now. GNS and we will do the other lab because if you put 6 routers in GNS, 6 to 7 routers, so it will start hanging.
Okay.
Okay, so do it in packet tracer, the basic configuration. The other labs, advanced labs, will do it on GNS.
Okay.
Okay. I'm not sure about the RAM configuration on all your PCs. That is why. In case if RAM is less, it would not take the load of 6 routers. Okay.
Okay.